All right, everybody, in this video for 3.5, we're going to look at the derivative of trig functions. So the first thing we're going to do, guys, is we're going to take a look at the graphs of sine and cosine, and then use those graphs to come up with their derivative. So, things you want to remember about sine and cosine is they're periodic functions. We're only going to look at one period from 0 to 2 pi. So the first thing I'm going to do is break my period up in a quarter period. So if that's 2 pi, pi is going to be about right there. We got pi over 2 and 3 pi over 2 here. So now if we take a look at sine, the sine function, you might remember, starts at 0. So you got a point at 0, 0. Quarter period's got a maximum of 1. Then halfway through it's got a 0. 3/4 of a period, it's a minimum of -1, and then it comes back to 0. So you get this curve that looks like this. Now, obviously, I didn't do a great job of scaling this. I'm going to just fix this piece here just a little bit. Move it right about here. Now, if we're going to try to identify the derivative of this function, we want to use slopes of tangent lines. And the easiest place to kind of recognize what the slope of the tangent line might be is at these maximum and minimum values. So you have this horizontal tangent here, which would correspond with a derivative of 0. You have another horizontal tangent at this point, again, which would correspond with a derivative value of 0. Now, we have to basically be able to find out what's going on in these other places. Well, if we chose here, the sine curve is going to continue to go, but if we drew a tangent line there, it's not obvious from our picture right here, but that is going to have a value of 1. So there's going to be a point there. And if you look at those slopes are going to get less and less steep as you approach 0. So they're going to be positive numbers, but they're going to, get closer and closer to 0. Whereas on the other side of that horizontal tangent, those slopes are going to be they're going to be negative values. They kind of start at 0 and become more and more negative until you get to this point where you're going to have a tangent, a slope of the tangent line of -1. So it'd come down here, and again, those values are going to stay negative until you get to this point, and then they're going to be positive until you get to this point, which is going to max out at the positive value of 1. And if you put those together and you were to draw the graph through those points, what you would see is it's going to look like this. Now, that should look familiar to you guys because that is the graph of cosine. And what that tells us is that the derivative of the sine function is the cosine function, which is pretty cool that relationship exists. Now, if we did the same thing for cosine, right, where we broke it up and we looked at that, again, we'll go pi, we've got pi over 2, and we've got 3 pi over 2. Again, with cosine, we just actually have the graph in blue right there, but cosine has a maximum of 1 at the beginning. All right, then it has a 0, then a minimum of -1, a 0, and then back to that positive 1. All right, so if you sketch that curve, the graph looks like that. And if you kind of follow that same idea of a pattern, we're going to start, there's a horizontal tangent here, there's a horizontal tangent here, and a horizontal tangent there. So those are all going to represent points of our derivative. So the derivative is going to be 0 at 0. It's going to be 0 at pi, and it's going to be 0 at 2 pi. And your initial thought might be, oh, okay, well, sine has zeros at 0, pi, and 2 pi. So the derivative of cosine is sine. Well, you got to be a little bit careful because if we took a look at the slope of the tangent line at this particular point right here, that's going to have a negative slope. it's actually going to be negative 1. So the derivative would be negative 1 there. Whereas at this point, that slope is going to be positive 1. All right. And the derivative ends up looking like this. So instead of sine, instead of the derivative of cosine being sine, it's actually negative sine. So y prime is equal to negative sine of x. So, that's one way to see what the derivative of sine and cosine are. And we're going to want to, in a way, memorize these, but be able to apply them. So if we come down here to some of the other examples, we're going to use that idea. The derivative of sine is cosine of x. The derivative of cosine of x is negative sine of x. So keeping track of our signs is going to be important. So if we take a look at number 3, we want to find y prime. We can use the constant multiple rule. So we're going to have negative 4 and then times the derivative of cosine, which is negative sine of x. A negative times a negative is a positive. So our derivative in this case is just 4 sine of x. If we come over here to 4, we actually don't have the ability at this point for us to take the derivative of this function right here. So we're going to skip this example, and we'll come back to it another day. Because in the next class, we will learn how to take the derivative when there's a negative there. But at this time, we don't have the ability to do that. So we had a typo in the problem. We're going to skip 4. All right, then if we come down to the next example, take a look at number 5. We've got y equals the quantity square root of x plus sine of x times the quantity of 2x squared plus 1. Now, one thought might be to distribute through and take the derivative that way. That way you might think you don't have to use the product rule. But really, because of that sine of x, we're going to need the product rule no matter what, no matter how we do this problem. So that's how we're going to approach it. We're going to use the product rule because we have the product of two functions. And I'm going to go ahead and rewrite this as x to the 1/2 plus sine of x times 2x squared plus 1. Now when we go to take the derivative, right, we're going to do y prime. So remember, the product rule is the derivative of the first function times the second function. So when we go to take the derivative of the first function, I'll do that in black. You're going to use the power rule for the x to the 1/2. It's going to be 1/2 x to the negative 1/2 plus, because it's a sum, the derivative of sine of x is cosine of x. We are going to multiply that by the second function, 2x squared plus 1, and then it's plus the derivative of the second function, which in this case is going to be 4x using the power rule, times the first function, x to the 1/2 plus sine of x. And at that point, all that's really left to do would be to expand it. You know, the calculus has been done at this point. We could expand it and see if anything combines to simplify it down. So we would have to distribute. So 1/2 times 2 is going to be 1. X to the negative 1/2 times x squared is going to be x to the 3/2. And then you got your 1/2 x to the negative 1/2 times 1. So it's 1/2 x to the negative 1/2. We got cosine of x times 2x squared, so we can call that 2x squared cosine of x. Cosine of x times 1 is plus cosine of x. Plus, we're going to distribute the 4x. We get 4x to the 3/2 plus 4x sine of x. Now, that doesn't help us simplify it too much, but there are some like terms. We have x to the 3/2 here, 4x to the 3/2 there. So we can combine those where we get 5x to the 3/2 plus. Now I'm going to rewrite this so the exponent's positive, so that's going to become 1 over 2x to the 1/2, or you could write that as root x, plus 2x squared cosine of x, plus cosine of x, plus 4x sine of x. So you can see, while the derivative of sine and cosine are relatively simple, some derivatives can become fairly complex. And it's very important that we take our time, look at the function, decide which rules we're going to need in order to take those derivatives. All right, let's keep moving. We'll take a look at number 6. So we have h of x is equal to cosine of x over 3x cubed. So at that point, we are going to have to use the quotient rule because we have cosine of x divided by 3x cubed, a function divided by a function. So h prime of x is going to be the derivative of the numerator. So the derivative of cosine of x is negative sine of x times the denominator. So we've got 3x cubed minus the derivative of 3x cubed is 9x squared times cosine of x all over the denominator, which is 3x cubed quantity squared. So if we look at this, we can kind of break this down and simplify it to, we've got negative 3x cubed sine of x minus 9x squared cosine of x over 3 squared is 9, x cubed squared is x to the 6th. And then at that point, it is a fraction, so you'd want to see, is there anything that can reduce? Well, hopefully you recognize that everything is divisible. There's a negative 3x squared in every one of these terms. So we can reduce out that negative 3x squared. So that's going to give me x sine of x when I take out the negative 3x squared plus 3 cosine of x over, and if I took out the negative, I would do negative 3x to the 4th. If I didn't put the negative in the denominator, it would go in the numerator, and you would have negative x sine of x minus 3 cosine of x over 3x to the 4th. But either way, one of those is how you would write the derivative of that function. So things you need to be remembering at this point are, if there's a product, we have to use product rule. If there's a quotient, we have to use quotient rule when we're taking derivatives. All right, so let's take a look at the next example. So when we go to take the derivative on number 7, we have a quotient. Okay, so quotient rule is going to come into play first. Guys, I'm actually going to stop the video right here, and we will continue in part 2 of this.